Welcome to the world of physics. Motion in one dimension is the basic component of all motion. Now let's begin to discuss uniformly accelerated motion. A general three-dimensional motion is equivalent to a system of three linear motion along three axes of a rectangular coordinate system. Thus, the study of one-dimensional accelerated motion forms the building blocks for studying accelerated motion in general. In order for you to really understand UAM or uniformly accelerated motion, let us first unlock the different terms that you will encounter as we go through our discussion. First is scalar quantity. When we say scalar quantity, it is a quantity that is fully described by a magnitude only. It is described by just a single number. Examples of this are speed, volume, mass, and time. Next is vector quantity. When we say vector quantity, it is a quantity that has both magnitude and direction. Some examples of vector quantities are force, velocity, acceleration, and momentum. As you can see in the GIF presented, weight is considered as vector quantity because it has a downward direction due to gravity with a constant value of 9.8 meters per second square. Next is position. It is a vector quantity that describes the location of an object. As you can see in the figure, the O is the origin. This position is the starting point of the man. Values to the right of the origin are positive, while values to the left of the origin are negative. Next is distance and displacement. Distance is a scalar quantity that describes how far an object moves, while displacement is a vector quantity that describes the overall changes in object's position. Distance is the total length of an object travels, while displacement is the shortest length between an object. Next is speed versus velocity. Let's discuss how these two differ from each other. First is speed. Speed is scalar quantity, so it has only magnitude. It is also defined as how fast an object is moving. The numerical value of the area under the curve of speed time graph is equal to the total distance traveled by the object. The formula for speed is distance all over time, and the unit of measurement is meter per second. Second is velocity. Velocity is a vector quantity, so it has a magnitude and a direction as well. It is defined as the rate at which an object changes in its position. Comparing velocity and speed, velocity has either positive or negative values, while speed has only positive values. The formula for velocity is displacement over time. The unit of measurement is also meter per second. Let's have an example. A sprinter ran and made 2 laps around 400-meter track. What were his average speed and average velocity if he ran for 200 seconds? First, let's identify the given in the problem. First is distance with 400 meters times 2 because the sprinter made 2 laps, resulting to 800 meters. Second is displacement. We have 0 meter because the sprinter returns to its original position. And then lastly, time. We have 200 seconds. Since we are looking for the average speed and average velocity, let us first solve for the average speed. Average speed is equal to distance all over time. Substitute the given. 800 meters all over 200 seconds is equal to 4 meters per second. Next, let's compute for the average velocity. The formula for average velocity is displacement all over time. Substitute the given 0 meter as the displacement all over 200 seconds as the time is equal to 0 meter per second. Next is acceleration. Acceleration is a vector quantity that is defined as the rate at which an object changes in velocity. An object is accelerating if it's changing its velocity. The formula for acceleration is change in velocity all over time, which means acceleration is equal to final velocity minus initial velocity all over time. And the unit of measurement in acceleration is meter per second square. Let's have an example. A moving car has a velocity of 5 meters per second, and it took 10 seconds to reach its destination. What is the acceleration of the car? The given r velocity is equal to 5 meters per second, time is equal to 10 seconds, and we are looking for the acceleration. The formula we are going to use is acceleration is equal to velocity all over time. Let's solve for the acceleration. Acceleration is equal to velocity all over time. Let's substitute the given. 5 meters per second all over 10 seconds is equal to 0.5 meter per second square. Let's have another example. If the car started from 5 meters per second and increased to 15 meters per second in 40 seconds, what is its acceleration? Let's identify the given in the problem. Final velocity is 15 meters per second. Initial velocity is 5 meters per second. Time is 40 seconds, and we are looking for acceleration. We need to use the formula A is equal to final velocity minus initial velocity all over time. Let's solve for the acceleration. Acceleration is equal to final velocity minus initial velocity all over time. 15 meters per second as the final velocity minus 5 meters per second as the initial velocity all over 40 seconds as the time. 15 minus 5 is equal to 10 meters per second all over 40 seconds is equal to 0.25 meter per second square. As you can see in the picture, velocity versus time graph is a straight line. Always remember that acceleration is constant, meaning the acceleration in motion does not change. The acceleration is a set and constant in the entire motion. Now, using the formula of velocity, average velocity, and acceleration, we can now derive formulas. If we want to know if displacement changes with time, when an object is in uniformly accelerated motion, we are to derive from the formula of velocity, which is displacement is equal to velocity times time. Second step, if the problem has an average velocity, we can substitute the average velocity formula to velocity. So displacement now is equal to final velocity minus initial velocity all over 2 times time. From the equation, if the final velocity is not given, how are we going to get the formula for that? First, we need to arrange the second formula in acceleration to get the formula for final velocity. Let's have cross multiplication. A times t is equal to final velocity minus initial velocity. Arrange the formula that will give us final velocity is equal to initial velocity plus acceleration times time. Step 4. The formula will be substituted to our bigger formula. Using the formula in step 2, which is displacement is equal to final velocity minus initial velocity all over 2 times time will give us displacement is equal to initial velocity plus acceleration times time minus initial velocity all over 2 times time. We should combine same variables resulting to this equation. Displacement is equal to 2 initial velocity minus acceleration times time all over 2 times time. Step 6. Distributing time will give us displacement is equal to 2 times initial velocity times time minus acceleration times time squared all over 2. Simplifying it further will give us displacement is equal to initial velocity times time plus acceleration times time squared all over 2. This equation tells us that the displacement of body is directly proportional with the square of time, meaning if time increases in equal interval, displacement increases quadratically. If we want to find out how final velocity is dependent on the displacement, we are going to use the formula d is equal to velocity times time and substitute the velocity to the average velocity formula and the t to the formula of acceleration when t is given. That will give us final velocity is equal to square root of initial velocity squared plus 2 times acceleration times displacement. Let's have an example. An airplane from rest accelerates on a runway at 5.5 meter per second square at 20.25 seconds until it finally takes off the ground. What is the distance covered before takeoff? The given r acceleration is equal to 5.5 meter per second square. Time is equal to 20.25 seconds. Initial velocity is 0 meter per second and we are looking for the displacement. The formula we are going to use is initial velocity times time plus acceleration times time squared all over 2. Let's solve for the displacement. Substituting all the given will give us 0 meter per second times 20.25 seconds plus 5.5 meter per second square times 20.25 seconds square all over 2 is equal to 1130 meters. Let's proceed to free fall. Free fall is a state of body that moves freely in any manner in the presence of gravity. Assuming no air resistance, all problems involving motion of falling objects can be solved by using equation for accelerated motion. The displacement of falling objects in given period of time is computed by the equation displacement is equal to initial velocity times time plus gravity times time squared all over 2. The final velocity of falling objects can be calculated by these equations. First is final velocity is equal to initial velocity plus gravity times time, and final velocity is equal to square root of initial velocity squared plus 2 times gravity times displacement. If we are going to observe, all A were changed to G because gravity or acceleration due to gravity has a major influence in free-falling bodies. And as a reminder, all the values of initial velocities are also zero because when an object falls freely, the starting point is zero, or it starts from rest. Let's have an example. The time a male bungee jumper is freely falling in 1.5 seconds, what is the velocity of the jumper at the end of 1.5 seconds? How far does he fall? The given in the problems are initial velocity is equal to 0 meter per second, time is equal to 1.5 second, gravity is equal to 9.8 meter per second square. First, let's solve for the final velocity. Final velocity is equal to initial velocity plus gravity times time. Substitute all the given. 0 meter per second plus 9.8 meter per second times 1.5 seconds is equal to 14.7 meter per second. And lastly, let's solve for the displacement. Displacement is equal to initial velocity times time plus gravity times time squared all over 2. Displacement now is equal to 0 meter per second plus 9.8 meter per second square times 1.5 second square all over 2 is equal to 11.03 meters.